Dear students, today we will learn the RS nomenclature in flying wedge formula structures. We have already learned the how find out the RS configuration in Fisher projection formula. Today we will learn the formula which, chemical formula in flying wedge projection. We have some rules to assign R and S configuration. These are: first you have to find out the firstly chiral center, then according to the sequence route give the priority to the groups, and then your fourth priority group or least priority group should be pointing away from the observer. Then we will find out its R and S configuration according to the prior sequence rule. Whether your 1, 2, 3 rotation is clockwise, then your configuration should be R, and when your rotation is the anti-clockwise, then your configuration should be yes. When you represent your compound in a flying wedge formula, there are three ways we can represent these fourth priority group. Whether fourth priority group is pointing towards the observer, whether fourth priority group is away from the observer, and in one case your fourth priority group is present at the plane position. Okay, there are three cases by which we can represent the flying wedge formula where fourth priority group is present. That first case is when your fourth priority group is present at the away from the observer. Okay, that dotted wedge line means that it is away from the observer. That is first case. Second case is when your fourth priority group is present at the solid wedge line, and third your fourth priority group is neither present on solid wedge line or neither present on dotted wedge line. It is present at the plane of bonds. Okay, these bonds are present in planes, or another way you can show like that way your fourth group is present at that position. Okay, like that three ways you can represent the fourth priority groups in a wedge formula. Let us see some example. By using this example, we will try to find out the RS nomenclature in different forms of the structures of flying wedge. The first, that is first way we can represent the molecule where your fourth priority group is present at the dotted wedge line, and dotted wedge line means the your group is pointing away from the observer. Okay, we have some rules. That rules when you assign the R or S configuration, your fourth group is pointing towards away from the observer. When such condition is there directly we can give the directly the your nomenclature put as it is. Okay, if suppose R configuration is there, you say that the R configuration is there. Okay, like that way we have example. In this case Br is there, Cl, F, and hydrogen is there. Hydrogen has the fourth priority group which is pointing away from the observer. This is the essential condition when you assign the R and S configuration. Bromine has its atomic number 35, chlorine is the 17, and 9 is the fluorine. Okay, therefore the four different group is attached to the central carbon atom, that is a chiral. Okay, chiral carbon atom we can represent like that. The four different group is attached to the central carbon atom. Then according to the atomic number we can predict its priority. Okay, bromine has the 30, its priority should be 1. Then chlorine 17, its priority should be 2. Fluorine has the 9 atomic number, then its priority is 3, and fourth priority group goes to the hydrogen. Okay, therefore 1, 2, 3 by rotation you can say that it is anti-clockwise rotation. Therefore if your fourth priority group in flying wedge formula is away from the observer, then your that is anti-clockwise rotation, therefore its configuration is R and it remains as it. So we not change R to S. Okay, such changes is not we can does in this for such way you represent the fourth group is away from the observer. There is no need to change the R configuration to S. If there is a second condition, okay, such condition is there. Fourth group is away, not away from the observer. Fourth group is pointing towards the observer. Okay, that is solid line. Is fourth group is represented by the solid line. It means it is pointing towards the observer. Okay, therefore we have one example is there. If suppose this case fluorine is there, hydrogen is pointing towards the, chlorine is there, and the bromine is there. Okay, therefore bromine is the 1, chlorine is the 2, and the fluorine is the 3, and your fourth priority group is pointing towards the observer. Okay, according to the some rules, when you assign the R and S configuration, your fourth group should be away from the observer, pointing away from the observer. But in this case, your fourth group is not pointing away from the observer, it is pointing towards the observer. Therefore, in this case, your rotation is the anti-clockwise. 1, 2, 3. Okay, your movement should be the 1, 2, 3. Okay, like that way you have to rotate your priority. And after rotation, you can found that it is anti-clockwise rotation. And therefore in this case anti-clockwise rotation means the configuration is, and S changes to R. S changes to R. In this case your configuration is like that, S changes to R, because your fourth priority group is pointing towards the observer. Then such condition or such flying wedge formula, your fourth group is pointing towards the observer, then you have to change the configuration, the configuration observer you have to change to the other. Yeah, if suppose there is R configuration, it changes to S, and if suppose there is a S configuration, it changes to R. Okay, this is a third way you can represent. The fourth group is first way you can represent. Your fourth group is away from the observer, and second example is the fourth group is near to the observer. And how to configuration is calculated if such two cases is there. Case number third, your fourth priority group is present along the planes. What will be its configuration? We have the same example. Okay, if suppose hydrogen is present in this case at the plane, its atomic number is 1, therefore it should be 4 priority group. Okay, and we have bromine, chlorine, and the fluorine is there, and we have known that the bromine has the atomic number 55, therefore its priority is 1, chlorine has 2 priority, fluorine has 3 priority, and 4th priority. Therefore rotation should be 1. In this case we can rotate any 3 bonds, or we can twice exchange of groups. So two way we can represent this formula. Okay, if suppose we have such type of group is there. Okay, therefore if suppose this is pointing away, therefore you can rotate, and you are like that way rotation. Okay, it remains this remains constant, any 3 group. Okay, if suppose 4 priority group is green, then by rotation up, and it's plane, it's looking to the planes and is away. Therefore by rotation you can green priority group should be away from the observer. Okay, but one bond you remains the constant. Okay, therefore any three groups, okay, hydrogen will move to bromine position, chlorine move towards fluorine position, chlorine move towards the hydrogen, and bromine moves to chlorine, and one of the group remains constant, its position is not changed. Okay, after such rotation you can found that your hydrogen will take the position away from the observer, and bromine will move to the pointing towards the observer, then chlorine take the position of the hydrogen. Okay, like that you give the fluorine remains as it is its place. Okay, therefore it's number 1, it's number 2, number 3, and the 4. Your rotation should be 1, 2, and 3, not from 3. Okay, 1, 2, and 3. Yes, rotation as it is put there because your fourth priority group is away from the observer. Okay, according to rule, when you assign the R and S configuration, your fourth priority groups always away from the observer. If not, then you have to some changes make there. If suppose in this case second we changes S changes to R, and in this case we have first method, you can rotate any three groups and achieve a condition where your fourth group must be away from the observer. Then second, that is the first way you can rotate any three groups. Second way is you can exchange any two groups. Okay, its configuration, yes, okay, we already perform this. Yes, configuration is there. The second method, same, we can try to find out its configuration. Second method is you can rotate any two exchanges will be there with the instead of rotating any three groups, you can exchange any two groups or atomic. In this case, you exchange bromine to hydrogen and hydrogen to bromine, and chlorine to fluorine, and fluorine to chlorine. Okay, like that way, two exchange within one step we have performed. Therefore hydrogen is there, bromine takes the position of the hydrogen, fluorine will take the position of hydrogen, and fluorine in place of fluorine there should be chlorine. Give them its priority order. Bromine has the 1, chlorine has the 2, and third is for fluorine, and the hydrogen has 4 least priority group. Therefore rotate 1, 2, and 3. Okay, therefore your fourth priority group is away from the observer, therefore configuration is yes, and by using the first method configuration was yes, and by using this method configuration is also yes. Therefore if your fourth group is present along the plane, then you have to exchange twice group, or you can rotate any three group. Your configuration is not changed. Okay, like that way we can, by using the if your compound is present in a flying wedge formula, then you can predict R and S configuration by observing these three cases. First case, if your fourth group is away from the observer, therefore there is no need to change the observer configuration, it should be remains constant. If fourth group is pointing towards the observer, then there should be a change in configuration takes place. If suppose yes configuration is there, it changes to R if fourth priority group is pointing towards the observer. And third and last possibility is your fourth group is present along the plane, then in this case you have to exchange any two groups and then try to find out R and S configuration. Okay, this is all about the we have such three conditions. Now we will discuss some examples regarding R and S configuration. Okay, all these Fisher projection formula also, and also the cyclohexane chair form molecule is there. We can find out its configuration. Then our flying wedge, some example from the flying wedge formulas also. Let us see some example. We have some problems. By this we can solve this problem, then you will definitely solve any, you can find out the configuration of any molecule, any chiral molecule, any chiral carbon. Okay, this is one of the example is there. If central metal atom is having attached to the, if attachment is different, all attachment is different, therefore according to the atomic number we can predict its priority. But the problem is arises when carbon has the same atom is attached, then we have to find out which group should have the least priority or which group has the higher priority. Okay, we can find out if carbon has same attachment. Okay, so chiral carbon has the same attachment is there, then we will look the next atom is attached to it, and by observing this we can predict the whether it has the R configuration or whether it has the S configuration. Okay, if you consider this, that carbon, okay, that carbon there is attachment is carbon, direct attachment is the carbon and carbon. Second carbon, when you look that carbon, there is attachment first carbons, oxygen and the carbon. Okay, there oxygen, carbon. In this case, there is a 2 hydrogen is there and 1 carbon is there. Okay, therefore carbon, hydrogen attachment there. This oxygen has the, no doubt, atomic number is more than the carbons, therefore it should be priority is 1. And then next find out the which has the highest priority. We will choose the which has the highest priority. Okay, if you observe all these things, you can find this carbon attached to the oxygen which is having the, okay, if the same attachment is there, we will find the next atom attached to it. Okay, for this carbon, next atom attached is the oxygen, its atomic number is higher, therefore second priority will be given to this group. Then find out within these two groups which is having third priority group, you can find that this carbon attached to 1 carbon and 2 hydrogen, and this carbon attached 3 carbons, therefore obviously we will give the third priority to this carbon and fourth priority to this carbon, and then try to rotate 1, 2, 3. Okay, your rotation should be 1, 2, 3. 1 is there, 2 is there, and third. You not go like that. You go 1. There is no matter how you go from the 4. Okay, 4 is we consider it's pointing away from the observer. Okay, O, H, and then second, and then third. Your rotation is the R. Okay, we have seen that if your fourth priority group is present vertical line, then your configuration, no change in configuration, you put R configuration as R and S configuration is S. In this case, your rotation is the anti-clockwise, therefore its configuration is R. We have another example by observing this, some double bonded carbon is there. Okay, there is some confusion is always there. By observing this example, you can this such confusion will be removed. The second example we have, the type of example is there, aldehyde is there, OH is there, and CH2, OH, and hydrogen is there. In this case, you found that 2 carbons, the attachment of chiral carbon, there is a 2 groups, the attachment is the same. Okay, no doubt, oxygen with higher atomic number, it is having the 1 priority. For least atomic number is hydrogen, there are 4 priority. We have to find out which should be 3 priority. We'll go which group. Okay, therefore we know that double bond we can represent like that. Okay, C directly attached O. Okay, O directly attached will be written first. Okay, directly this oxygen directly attached, and then we attach to this, we satisfy this valency if group is directly actually present. Okay, then double bond we can write next double bond oxygen is there, but we not satisfy this valency because it's actually not present there. But for the priority we'll give such type of bifurcation we show there. Okay, like that one. Okay, this valency. Okay, those group is actually attached. We fulfill these valencies. Okay, this now there is no problem. There is hydrogen and the oxygen is attached. Okay, fourth group and the first group. Okay, therefore for this carbon there is attachment hydrogen and the oxygen, hydrogen and the oxygen. For this carbon there is attachment oxygen and the hydrogen. By observing this, it's completely we can gain the which is having the third priority. This is having the third priority because in this case 2 oxygen is the attached. Okay, then we can find out the its third priority group and the fourth priority group. Okay, the 1, 2 okay, this is having the 3 priority group and second priority group. 1, 2, 3. Okay, 1, 2, 3 you can rotate like that. And your fourth priority group is present at horizontal line, therefore S configuration changes to R. Okay, already we have seen some rules where you have to change the configuration. First configuration you have to flip to the R. Okay, S flip to the R, S changes to R. Okay, therefore in this case your configuration is changes S to R. Okay, this is the second example. Then in example we have seen the how to represent the if multiple double bond is there. Now we have another example is there which is present in the form of the Wedge formula. Okay, such example is there. NH2 is there, central carbon atom attached, hydrogen is pointing away from the observer, CH3 is away from the observer and hydrogen is pointing towards the observer. Okay, let us try to give the priority to these different groups. Okay, we know that the nitrogen is have the 7 its atomic number, therefore first priority should be to the nitrogen, then fourth priority give to the hydrogen, then third priority. Okay, then directly oxygen is attached. Okay, the carbon is same, but next atom attached to carbon is the oxygen in this group, and this next next atom attached to this carbon is the hydrogen. Therefore the second priority should be goes to the COH group, and for third priority goes the methyl group, CH3 group. Okay, therefore your rotation should be 1, 2, 3. Yes configuration, but your fourth priority group is pointing towards the observer. But according to our rule, your fourth priority group should be away from the observer. Therefore, in this case, S changes to R, and your configuration should be R. Okay, from where your rotation is there 1, 2, 3, and your configuration is changes to S to R, because this is anti-clockwise, and anti-clockwise is yes, and your fourth group is not away. Therefore if it is not, then yes group is changes to the R. Your configuration is the R configuration. Nitrogen has the 7 atomic number and carbon has the 6 atomic number. Therefore like that way you can rotate and your answer will be the R configuration. Then another example which is a simple example is there, belongs to the, okay, like that example, flying wedge formula is there. Okay, in this case you have the one number is the bromine, obviously because atomic number is 55, then chlorine is the 217, carbon is the 63, hydrogen is the 4. Therefore your rotation 1, 2, 3. Okay, and your fourth group is pointing away from the observer. Therefore 1, 2, 3 your configuration should be R. In this case, configuration is not changed because your fourth priority group is away from the observer. Okay, next example. Such example is there. Okay, then find out the priorities, which group should give the priority first, which group give the priority second. Okay, in this case you can find there is a carbon direct attachment to the central metal atom, there is a carbon is there, and that is hydrogen. Okay, therefore which will have the okay, you can find that if same attachment is there, you have to look the next group or atom is attached and then find which is having the higher or priority number. Okay, in this case, if that has carbon attached to hydrogen, okay, and that is next carbon. In this case, there is the two carbon is attached and next is the hydrogen. In this case, two hydrogen and one carbon is there. Okay, like that same situation is there. Okay, if such condition, you can find the next carbon. Next carbon is having the two carbon attachment and one hydrogen. For this carbon, two hydrogen and one carbon. Okay, therefore this will be your higher priority group than this. Okay, you can find like that. If you find the next group is also same, then you go towards the next atoms we attach to the particular atom. Okay, therefore when you observe that, definitely this is having the first priority group, then second priority group to this, third priority group to this, and fourth is there. Okay, therefore rotation 1, 2 and fourth means yes changes to R. This is the configuration. Yes changes to R. In this case, yes changes to R. Okay, simple example is there, but in this case it's not clarified. Next group it attached. We have to use the another attached group and find out the which atoms is attached to this and try to find out its priority. Okay. The next example is CH2, CH3, CH3. Okay, this is again Wedge in Wedge formula. Wedge. Okay, then obviously oxygen has the one priority group. This group is bigger than this second, third, and the fourth. Okay, therefore you can rotate 1, 2, 3. 1, 2, 3. Hydrogen fourth group is away from the observer. Therefore, clockwise rotation, your configuration should be R. Okay, like that way you can find out its configuration. Now some example is there again. Try to find out. We'll try to find out which what is its configuration. Some confusion is there. We can remove the confusion and try to find out its actual how to overcome this problem. CH double bond CH2. Again, it is represented in a Wedge formula. Okay, in this case we have also the central carbon has the all group attachment is the same, and in some cases there are the double bond is also there. Okay, therefore we can by the we know that how the double bond is represented. Okay, this is the CH, okay, H and double bond there. Okay, one double bond we written like that, and its bracketed term is we will fulfill its configuration, and next double bond we can represent like that, but its configuration, its valence is not completed. Okay, the imaginary carbon we have shown the double bond, we split this double bond. Okay, after splitting you will obtain like that, and hydrogen is there. One is we written this CH2 and its configuration, its valence we have computed. And next we written the carbon. Okay, we can split this double bond. Okay, already we have seen these rules. Then this is over. Then there is no double bond in this case. Okay, there is oxygen is attached to there, therefore we fulfill this configuration. And second bond, there is we have written this oxygen in bracket and hydrogen. Okay, therefore its valence is completed. Not completed valence is extra imaginary atom we have shown, element shown, therefore we have not shown. Its valence is remain incomplete. Okay, let us try which group should be the higher priority. Okay, this carbon attached to the second carbon and the hydrogen. This is attached to the hydrogen carbon. This is attached to the hydrogen oxygen, and this attached oxygen and the hydrogen. Okay, no doubt this carbon has the 2 oxygen, its priority is the 1. This is having the 1 oxygen, there is no directly attached oxygen is there, atomic number is higher. Though these 2 groups have the 2 carbon is there, we not consider its higher priority. Higher priority should go that carbon has the oxygen, which is having the higher atomic number. Though it is having 2 hydrogen is there, it is having the highest 2 carbon is there, it not considered there. You consider this oxygen higher atomic number, therefore its priority should be 2. Then this group have the priority. Okay, number of branches there, 3rd priority and the 4th priority belongs to this. By rotate 1, 2, 3. Okay, this rotation is the anti-clockwise, therefore yes, and 4th group is pointing away from the observer, therefore yes as it is. Okay, your configuration should be yes configuration. Okay, this is some examples. By observing these, some doubts is created, is we have try to minimize it by using some rules. Then some example is there, how to give the nomenclature in the cyclohexane. By using one example, we will describe how to give the R and S nomenclature when you are there is a chair form of the. Okay, like that example is there. Okay, chair form is there, and find out it is chiral center and try to find out the configuration. Okay, therefore in this case there is carbon is there, in this case carbon. Okay, therefore if you consider these chiral centers, this should be have the 1 priority. This has the carbon is attached, 2 priority, 3 priority and the 4th priority. Then 1, 2, 3, its configuration should be R. In this case priority, okay, this carbon has 2 carbon is attached, 1st priority, 2nd and the 3rd priority. You can rotate like that. S changes to R because 4th priority group is pointing towards the observer. Okay, like that way you can also find out or predict the configuration of the chiral center which is present in cyclohexane and in chair form. This is all about the how we can predict R and S configuration in flying wedge formula, in Fisher formula and in chair form molecule. Thank you very much.